Alright, so scrolled over to the next page. Here they're mentioning a little bit more about what they were talking about in the previous page. This composite function h of x is equal to 2x plus 3 is a composition of two functions, f of x equals 2x and g of x equals x plus 3. Typically we write it, the composition function h of x is really equivalent or equal to g of f of x. So here's how we say it, g of f of x. I really won't be using this part down here. Typically this is how I'll be expressing it here. Note, when h of x is written as g of f of x, note that a function f is applied first. In other words, we deal with the inner brackets first. We deal with f of x, we do that function, and whatever we get as an output value, then we use that in the g function as its input value. First applied to the f function, and then the g is applied second. H is often referred to as a function of a function. Okay, so let's pause for a sec, scroll down. Okay, class example 1 is consider the composite function h of x equals x squared plus 2. Looks like they're taking x, it's being squared, and then 2 is subtracted. Describe in words two operations in order, in the correct order, which can be applied to x to end up with this. Well, that's basically what I was talking about. We want it to end up exactly like this. So what can be applied to x? X would be squared first, and then 2 is subtracted. So I won't write that out, but take x, square it, and subtract 2. Part B. Complete the diagram and write h of x as a composition of two functions f and g, where h of x is equal to g of f of x. Well, okay, so we can see that if we take x, our function f of x does the squaring first, and if we square x, we'll get x squared. G, the function g, seems to subtract 2. So we end up with x squared minus 2. So they're asking here, what does f of x actually do to x? What does it do? If we take x and we apply function f, what do we get? We get that. If we take x squared and apply g to it, what do we get? Well, we get this. So here they're just saying, what if we just took x? What does g2 do to x? Well, all g does is subtract 2 from whatever the input value is, whether it's x or whether it's x squared here. So that's what's happening here, where all we're doing is subtracting 2. So if we start with x, we'll get x minus 2. If we start with x squared, we'll get x squared minus 2. Okay, class example 2. Consider the composite function h of x equals x plus 4 cubed. Describe in words two operations in the order, in correct order, which can be applied to x to end up with this. So the trick is to look at x and see what happens to it first. So it looks like we've added 4, and then once we've added 4, the whole thing gets cubed. So add 4, add 4, then, sorry for my writing here, pretty bad on this tablet, then cube answer. Okay. part B of this is saying complete the diagram for this. So what we're doing here is we took x and we added 4. That's what was happening. And then we took our answer and cubed the whole thing. So whatever we got, we cubed it. So we'll, using just the function f, x will turn into x plus 4. That'll be our output for f. Using this as our input for g, the whole thing gets cubed. So we'll get x plus 4 brackets all cubed. All f does is add 4, all g does is cube. So f of x will equal x plus 4. Now if we take g of x plus 4 as they're suggesting here, we will get, just as we've written a moment ago, x plus 4 cubed. Now if the input is not for g, if it's not x plus 4, if it's just x, remember all g does is cube. So it's just going to cube the x. So we'll get x cubed. If we start with x, we'll get x cubed. If we start with x plus 4, we'll get x plus 4 cubed. Looking for a method of the composition of two functions. Saying here, consider these two functions, complete the diagram, to determine a formula for the composition of the two functions, g and f. Sorry, my screen is playing little tricks on me here. Just have to get rid of that. Okay. Okay. So, composition, these two. Well, remember we go to the inner one first and we apply f to x, and then whatever answer we get, we apply g. So, looks like we take x and we multiply by 3, so we're going to get 3x. If we take this as our input for g, all it's doing is it seems to be taking away 5, subtracting 5 from whatever we put in. So if we put in 3x, it'll be 3x minus 5 we get as an output. So taking what we have here, showing that we f of x, when we apply f to x, we actually get 3x, and 3x will be our input for g, as we've written above, and then we apply g to this, we get 3x minus 5. This is a little bit redundant, these type of examples when we've written it up here, but it's just to emphasize what's happening. Use a similar technique to determine a formula for the composite function, this one. Now notice what this is. This is k of x, but k of x is a reversal of h of x. Here we're applying the g function first and the f function second. Okay. So use a similar technique to determine a formula for the composite function. So here we determined what it was. Well, let's see. We're going to take x first of all, and if we apply g, that will change into what? Now what is g? G, all g does is subtract 5. So, okay, we'll get x minus 5. And then we're going to apply the function f. What does f do to its input number? All f does is multiply whatever the input is, it multiplies it by 3. Well, this is our input now. Sorry, that doesn't look like a very good 5. Okay, so we are going to multiply this input by 3. So x minus 5 gets multiplied by 3. So that is equivalent to this composite function that they asked for. Okay, at this point, I've scrolled down and they're suggesting a method of how to find a composite function such as this. Okay, so we're going to be given f of x and g of x, and then determine the composite function, or g of f of x. So you may want to pause the video and just review these steps. It's really what we've been doing above. Start with this as your template. Replace f of x with its formula. F of x, whatever it is, goes in here. That will be your input value for g. Then apply the formula for g and write the answer in the simplest form. So it's exactly what we were doing above. So let me take you through that here. Notice we've been given two functions, 10x plus 1, 2x minus 5. We're going to start, it's saying determine basically g of f of x, this guy here. So start with that. So here it is. The method we're using is these steps here, which we actually have been using up till now. So they're just writing it down for us. Replace f of x with the formula for f. So still have g. And what is f of x? F of x is 10x plus 1. And basically that's it. Moving on to step 3, now we're going to apply that. This becomes our input value for g, just as previous examples. Now apply the formula for g. Well, g is 2x minus 5. In other words, whatever the input value is, such as x, it gets multiplied by 2 and then 5 is subtracted. Well, our input value here is 10x plus 1. That whole thing is replacing x up here. So wherever we see x in the formula, it gets replaced with 10x plus 1. So this gets replaced with 10x plus 1, but so does this. So we are going to get 2 times 10x plus 1. And then the rest of g of x is to take away 5. Write the answer in simplest form, so that's the final thing. We multiply out the brackets, we get 20x plus 2 minus 5. So plus 2 minus 5 is minus 3. Okay, class example 4. If f of x equals 2x minus 1, g of x is 3x minus 4. So let's just underline these two. They're asking for g of f of x. Well, I don't usually use this terminology. As I've said before, I usually use g of f of x like this. So what is that going to be? Well, as above, we're going to take f of x and put it in here. And then we'll apply the g function. Whatever's in here represents the input for g. So this whole thing is going to get multiplied by 3, and then we'll subtract 4. So 3 bracket 2x squared minus 1 is our input value that we got from our output value from f, function f. Okay, so 3 times the input function and then minus 4. We can simplify this by multiplying out the brackets. 6x squared minus 3 and then take away 4. That makes it minus 7. Looking at this, this is really g of x. In other words, they're applying the function twice. Okay, we'll take g of x. Now g of x is 3x minus 4. And now we are going to use that as our input value for g. This will become 3x minus 4. So this x value also becomes 3x minus 4. and simplifying, we'll get 9x minus 12, and minus another 4 is minus 16 in simplest form. Well, as you may have noticed, this is a rather long lesson. So the last page here is considering these two functions here and here. We're looking at the domain and range of a composite function. So it really depends on what the output equation is. This is really using x equal to 2. So let's write this in a notation we'll understand. f of g of x. So f of g of x. So we want to apply the g function first, the innermost function, followed by, in this case, f. So let us write f of g of x. Now g of x is the square root of x minus 1. Okay. And then we apply the f function. This becomes our input value for the f function. Here's our input x. So x gets squared, whatever it is. Now our input function is the square root of x minus 1. Now we are going to square that just like this gets squared and subtract 3. So that leaves us with x minus 1 minus 3. So really x minus 4. Now if our value for x is set at 2, then this would be 2. 2 minus 4, which equals negative 2 as our answer. You can try the next one. I'll give you the answer now. Actually, what happens is when you do it, you'll get an answer of 0 minus 1. So that's the square root of negative 1. So the answer does not exist here. Okay, that will not exist. But please try that, just like I went through this. The next one, g of f of the value 2. Now this is the opposite way around, so it's g of f of x, and we want x to be 2. Well, let's write out the formula first. F of x is x squared minus 3. So that's going to be our input value for g. And what does g do? It takes the input value and square roots. In other words, it replaces this x up here with our input value, whatever's in here. So in here we actually have x squared minus 3. So let's write the square root. Our input value is going to be x squared minus 3, and then we've got that whole thing there. So that I will replace this x with this. I guess we'll see if we can simplify that. I'm not sure we can. Maybe we should just pop in our value 2 now. So let's do that. If this is 2, it's going to get squared. 2 squared is 4. 4 minus 3 is 1. 1 minus 1 is 0. We're really taking the square root of 0. So what's that? The answer is 0. Back here, when we had 0, we've worked out the formula for f of g of whatever. This is also asking f of g of whatever. So when I simplified it down to x minus 4, really all you had to do was put 0 in here, and you would get a value of I'm just thinking that might not be the right way to show you how to do that. I guess up here we could have substituted 0 in here. 0 minus 1, yeah, we're taking the square root of 0 minus 1, and that's where it fails. at that point. We cannot, even though we're squaring it, it doesn't give us 0 minus 1, so square root of minus 1 squared must be minus 1. It doesn't work like that. If this number under the square root sign at any point is less than 0, there's no answer. So that's what I mentioned up here. And let's take our value here again, only we're substituting in 0 this time. So let's go from this point, because we already have g of f right here. So I'm going to take this here, we're going to fill in x to be 0, it gets squared, minus 3, close bracket, minus 1. So notice we have, this is going to end up being square root of negative 3 minus 1, or square root of negative 4. So answer does not exist, so no answer for this one either. State the domains of f and g. Well, let's look at it. Up here, what's the domain of this? Is there any number we can't put into x before it gets squared? No, we can square just about any number we like, so it doesn't really matter. So for f of x, domain is all real numbers. What about g of x? Well, we're looking at a square root, and x is under the square root. We don't want this value to be less than 0. In other words, x minus 1 has to be greater or equal to 0. So x has got to be greater or equal to 1, adding 1 to both sides. So that is the domain for g of x. Here it asks for the ranges. So for f of x, looking at this, well, this is a parabola. You can graph it with your graphing calculator. What it does is it will look like this. Normally you would have it here coming down and going round like this, but because it's minus 3, all the y values are shifted down by 3. So it actually comes down as low as negative 3 and back up. So this is negative 3. So for the range of this, f of x has to be greater or equal to negative 3. What about g of x? Well, remember what square root functions look like. This whole thing has got to be a square root, has got to end up, because this is a positive number under here, the square root has also got to be positive. And a function like this looks like, no, it always starts somewhere on the x-axis. In this case it starts here at positive 1. But as far as the range goes, because of the square root, our value for g of x cannot be less than 0. It has to be greater or equal to 0. Okay, I think I'll pause this here, and I will start part 3 because it's getting quite long.